exponential and a power function. So I'm going to start with an exponential function. They've given me a couple points to use. You may remember doing regressions in a previous unit. We're going to do a very similar thing for these problems. So begin by pressing Stat and then Edit. And you should see L1. You should see L1 and L2. If you don't see those, you can talk to me in class and I'll show you how to get those to pop up. Get your X's typed in L1, I've done that already, and get your Y's typed in L2. And if you need to pause the video to keep up with me, then pause the video. Once the data is typed in, go ahead and press Stat again. And this time we want to go to the Calculate menu. And as you scroll down, you'll see the different regressions we've done. And if you keep scrolling down far enough, you'll see our new ones we're looking at today, the power and the exponential. So this one said we wanted to do an exponential regression, so press Enter to select that, and then Enter a few more times, or this screen may not pop up, you may just have to press Enter. And you'll see that there is our regression equation. Notice that the exponential function means x is in the exponent, so we end up with y equals, this is important to have that, 4 times 3 to the x. And since there's an exponent, you can't multiply first, so you do not make that 12 to the x power. So that is my answer. And our application problems will work very similarly. So here's a set of data modeling the deer population after a certain number of months. So I'd like you to pause the video, enter this data in, just make sure you can come up with the answer that I came up with here. If you don't, ask me a question in class to see what happened. Otherwise, what I want to focus on is this part of the problem down here, using our model to then make a prediction. So I assume at this point you've paused the video and found this equation. If not, do that now. And so let's go ahead and figure out now what month we can estimate the deer population to be about 200. And so in this case, because they've given me the population, that's a y value. Oops, that's not what I was trying to do. That's a y value. And so I've plugged in 200 and then set that equal to the equation I wrote here. There's a few ways that you could solve this. I decided to solve it algebraically, and I'll kind of work you through those steps in a second. Otherwise, you could solve this by guess and check. That's what we had originally done in this unit, or by graphing. So let's begin by dividing both sides by 8.46. So 200 divided by 8.46. That's where I got the 23.64 from. And then, as we've talked about, to get rid of a base, we need to do a logarithm. So I need to do the log base 1.42 to get rid of a base of 1.42. So you can do that a few different ways. If you have the log base button, which my calculator does have, I can go ahead and just use that. If not, we can use change of base. And if you need to see that in another video, go ahead and watch that other video. So log base 1.42 of 23.64 gets me my answer of about 9. And of course they wanted to know what month, so the 9th month would be September. So there's how we can use one of these models to make a real life situation, to make a prediction about a real life situation. Our next problem looks very similar to what we've just done, so be careful. This time they ask us to write a power function, which is not exponential. This one does not have an x in the exponent. You'll see that when we run our model, the x is just a base with an exponent on it. So same idea, I've gone and typed the data in. If you need to pause the video and do that, do that. Remember, x is going L1 and y is going L2. So my data is typed in. Again, pause if you need to. Under Stat and then Calculate, this time we want to select the power regression. So scroll down a few times. Try not to go too fast this time and miss it on my calculator. There's your power regression. Again, just be careful because it's just that one keyword that tells you. Select Enter, press Enter a few times if this screen pops up to get down to Calculate. And notice in our model this time, it's a times x and then raised to the b power. So there's my a, I've rounded off two decimal places, times x raised to, there's my power. And for our last example, let's take a look at an application of doing a power model. Again, look for that keyword in the problem. That's the only thing that's going to tell you whether you're doing a power or exponential model. So pause the video, get this data typed in. Just make sure you can come up with the same power function that I came up with. This time it's the atomic number as the x and that element's melting point. Once you've done that, I assume you've done that at this point, they ask me a question then so we can make a prediction based on the model we just found. We want to figure out the melting point of francium, atomic number 87. So this time the atomic number is x, so we're plugging in 87 for x this time. Last time we plugged in for y, so just be careful of what they give you. They'll give you x or y. So I've typed this all in just for x, no working backwards required, and there's where I got my estimate of about 22.81